So let's find the value of Kt and Kb from the data given from this parameter. So it's easy to find the value of constant because it is linear relation. If we know the one value of current and torque, that is, we will have the rated current and rated torque, then we can find the Kt. It is torque divided by current. Output is torque, input is current. So any one value is enough. So we will have the rated value that we will derive from this parameter, and for the Kb we will have the one value, that is, we will find for the rated speed in the radian per second, and what will be the rated back EMF, what will be the back EMF at rated speed. So we will find it, and we will have the value of Kt and Kb. So I have already calculated it. So here, first of all, we need to understand it is 5 HP DC motor. That means rated power is given. 5 HP is rated mechanical power. Let's first convert the 5 HP into watt. 1 HP is equal to 746 watt or 745.7 watt exactly. So 5 HP is equal to 3728 watt. So 3728 watt is the output mechanical power. So voltage is 240 volt. Remember, it is output mechanical power. If we want the input mechanical power, we need the efficiency. Input power will be higher than the output. The speed is given, rated speed is 1750 rpm. So first we will convert the speed from rpm into radian per second. So pi by 30, using pi by 30 we will convert the rpm into radian per second. It's come to 183.17 radian per second. So this is rated speed. Now we are having the rated speed in radian per second, and we are having the rated mechanical output power. So torque can be found because output mechanical power is the product of speed and torque. If we want torque in Newton meter, then we can find it power divided by speed. So power, mechanical power, comes in watt when speed is in radian per second and torque is in Newton meter. So we can find the torque in Newton meter, the power in watt divided by the speed in radian per second. So 3728 divided by 183.17 is equal to 20.35 Newton meter. So this is the rated torque. So at this torque, if we supply the 240 volt, our speed will come to the 1750 rpm or say 183.17 radian per second. So we are having rated torque. Now let's find the rated current. To find the rated current, we have the idea of efficiency. If efficiency is not given, we can assume the efficiency. Here I have selected the efficiency of 5 HP DC motor around 75%. So assuming the 75% of efficiency, let's find the input power is equal to 3728 divided by 0.75, so equal to 4970 watt. So efficiency is output divided by input. So input is equal to output divided by efficiency. So it is come to 4970 watt. So now we are having the input power, we are having the input voltage, so we can find the input current. Because motor is continuously running at rated speed, inductance will not comes in the picture. So it is constant. At rated current we can find is equal to the input power divided by the voltage. So 4970 divided by 240 is equal to 20.7 ampere. So rated current, we are having rated current, so we can find the Kt, but before that let's find the back EMF, and rated speed is also given. Rated speed we know it is 183.17 radian per second. So let's find the back EMF at rated speed. So this rated current is flowing through the armature winding. This rated current is flowing through the resistance, and that's why if speed is constant, inductance will not comes in picture. Current is flowing continuously. So steady state value, voltage across winding will be the product of current that is flowing through the resistance 2.581 ohm armature resistance. So voltage across winding at rated speed will be 20.7 ampere multiplied by 2.581 resistance equal to 53.43 volt. So voltage across resistance or voltage across winding will be 53.43 volt at rated speed. So we are supplying the rated voltage of 240 volt. So and voltage appear across winding is only 53.43. So rest of voltage is back EMF due to back EMF. So back EMF can be find supply voltage minus voltage across. You can recall the circuit diagram of the DC motor that we have discussed. Back EMF is equal to 240 volt minus voltage across resistance or voltage across winding 53.43 and equal to 186.57 volt. So this is the back EMF at rated speed. So now we have all the required quantities and parameters. So KB back EMF can be find, output is back EMF and input is speed in radian per second. So 186.57 divided by 183.17, it is almost 1.02. KT is output is torque, input is current. Rated torque is 20.35 Newton meter, current is 20.7 ampere and it's come to 0.98. So this way you can see both come to almost 1. So we can keep it both value of KT and KB to 1. So this is how we can find the value of KT and KB, and now our model is ready. So this simulation model of DC motor is ready to run. Now I am hiding these parameters because we want to highlight this model. So what we will do now, our this simulation model of DC motor of the 5 HP, I will write this is 5 HP DC motor model is ready. So now let's analyze the model for the given parameters and validate it by simulating it. So we will do the simulation. First we will supply the full voltage of 240 volt by ensuring the load is 0. So load torque is 0, supply voltage is 240 and speed is in radian per second. So we will also measure the speed in RPM. So I will use one gain block. So this is radian per second and it convert into the RPM. So we need to convert 30 by pi. You can see I am enlarging so it is visible. So it is 30 by pi. One more scope I have used. I will also use the display to have the steady state speed. This speed will be in radian per second, this speed will be in RPM. So we will see both the response and the steady state speed for this. Let's simulate it. And check the response. So for the 0, no load speed is higher, it is not rated is 1750, but we can see speeds come to 2274. So no load speed, load is 0, it is higher in RPM and also it is not 183 radian per second, so it's higher. Let's see the response. You can see response here, the speed you can see. If you are finding the distortion or the not smooth response, then you can go to the simulation parameter and in the model configuration parameter you can change this refine factor. If it is 1, change it to higher value 10 or 20 like this or 30 to have the smooth response. So now let's see, apply the rated torque. What rated torque we comes to? We found it 20.35. So now if we put the rated torque 20.35, now what should be the rated speed? It should be around 1750 rpm. So we apply the full voltage 240 volt and let's simulate it. So it is 1777 rpm. So our model is okay and model is ready to run. Now we can go to the next session where we can attach this model with the model of electric vehicle, and we will see what are the problem arise when we are having the two separate model of DC motor or any electric motor and the vehicle. So hope you got the idea about the development of DC motor model and how to validate it. Our value of KT and KB all are okay because we have used the applying the full voltage. We have set the rated voltage, rated torque and no load torque speed have verified.